Previous class we have discussed about the S buffer register and what are the steps that is required to transmit the data serially. Now in this class we will be dealing it when writing the programs. So we will be writing a program to transmit the data serially in 8051. Okay. So directly I will be going back to the programs. So you all know what are the steps you need to follow. The first step what you are supposed to follow in case of your transferring the data serially in 8051 is you need to load your TMode register. So you have to load your TMode register. Then you have to decide under which mode of operation your serial controller is going to work. After deciding the TMode, you need to load the data TH because it is a auto 8-bit reload. So in this TH you will be loading your baud rate. Baud rate is nothing but bits data transfer, that is bits of data per second. How many bits of data you are going to transfer per second. So that will be defined in TH register. So the step-by-step execution I will show how exactly we need to go on with the program. First, as we discussed, we have to load the TMode register. So the first instruction what he had given is TMode #20. 20 means 0010 0000. It is H. So timer, it has got 4 modes of operation, that is mode 0, mode 1, mode 2, mode 3. Okay, here mode 0 is nothing but 13-bit timer. Mode 1 is 16-bit timer. Mode 2, it is your 8-bit auto reload where we are going to utilize it for your communication program. So in mode 2 only we are going to write the serial communication program. So 8-bit auto reload we have to use it. Why? Because we need to define the baud rate, because only with that particular baud rate your data should be transferred continuously in that particular program. So I will be selecting my mode 2. Now I will show the bit pattern of your TMode register. The bit pattern of your TMode register is going to be 4, 1, 2, 3, 4. So the bit pattern, it is going to be your 0th bit, 1st bit, 2nd bit, 3rd bit, 4th bit, 5th bit, 6th bit and 7th bit. So in this, the first 4 bit will stands for timer 0 and the next 4 bit is going to stand for timer 1. You consider, we are going to consider timer 1. So what timer 1 in mode 2. Timer 1 in mode 2 means here I will be putting 1 0. I am going to operate it as a timer, so here it will be 0 and 0. Since I am not going to utilize this timer 0, I will be using 0 0 0 0. Suppose if I am going to operate it at timer 1, my TMode register should be loaded with 20H, that is 20H. Move TMode 20H, that is given in the first step. So now suppose if I am going to use timer 0 in mode 2. Suppose if I am going to use timer 0 in mode 2. So here it will be 1, here it is going to be 0, 0, 0 because I am going to operate the timer by means of your software. So gate will be 0 and this bit stands for C bar T bar. Since I am going to operate it as a timer, T bar it is an active low signal. So if you give 0 over here, it will be acting as a timer. So 0 0 1 0 and here it is going to be 0 0 0 0 as we are not going to use this timer 1. Suppose if I am going to use timer 0, my instruction will be MOV TMode #0 to H. So either 20H will come or 0 to H will come depending upon whether we are going to use the timer 1 or timer 0. Next one is TH1. After the TMode register is loaded, I wanted to set my baud rate. Baud rate means suppose if I am using 4800 baud rate, after doing a calculation, that is TH1. TH1 is nothing but 8-bit auto reload. In case of your 8-bit timer, that is auto reload, the minimum count is going to be 00 and the maximum count is going to be FF. So in this, what is the baud rate I am going to set? 4800 bits per second. So if you convert this one to hexadecimal and if you do a calculation, you will be getting one negative value, that is -6. That we are going to load it onto my timer register high. Why I am using only TH in the sensor? For example, mode 3 as we discussed, mode 2 as we discussed, it is going to be your 8-bit auto reload. 8-bit auto reload. In this, the minimum count is going to be 00. The maximum count is going to be FF to maintain 4800 baud rate. And the calculations are already discussed in your third module, how to load the values of TH1. So after doing the calculation, you will be getting -6. So this particular bit need to be loaded onto your timer register. Since it is a 8-bit auto reload, we are going to focus only on the higher byte of your timer register TH. Suppose if we are using timer register timer 0, then you have to use TH0. Suppose we are using timer 1, means you have to load it in TH1. So in this program, as the TMode is 20 is loaded, we are focused on timer 1. So whatever further lines or instructions we are going to write, you have to concentrate on your timer 1. So you load this TH1 with -6 as an immediate data to set 4800 baud rate. Clear? Next one is your SCON. SCON in the sense serial control register. We all know that what is the serial control register bit pattern from the previous class. It is also a 8-bit register where these 2 bits will define the modes of operation. So here 00, I am going to operate it with mode 1. So 01, mode 1 is nothing but 8-bit UART with a variable baud rate. 8-bit UART with a variable baud rate. It is your mode 1, and here 0 I am going to give. Why? Because if I give the 0 over here, my return interrupt will not be enabled, will not be activated until it receives your stop bit. So here I am going to 0 and here I am going to 1 because I am going to transmit a bit of data. So here 0, 1, 0, 0, 0. Rest all is going to be 0. Therefore, load the data move SCON with 50 so that 8-bit 1 stop and return enable is enabled. That is receive enabled. Receiving the data is enabled. If all these 3 things to be happen, then SCON need to be loaded with 50H. Then these lines are common. It means that once your serial control register and your TMode register and your TH1 is loaded, TH register is loaded, you have to start your timer. So to start the timer, the instruction what we are going to use is set B TR. TR means timer run bit you are going to set. Timer run bit 1. So timer run bit 1, why I have selected in the sense, because in the initially I have selected timer 1 while configuring my TMode register. So as soon as I have started my timer, I wanted to transfer the data. To transfer the data, first I have to load my data onto my S buffer register. So to load the data onto my S buffer register, you select move S buffer. Here we planned to transmit the letter Y. So S buffer comma hash. Since it is a ASCII code, you put within a code Y. So when you do so, here S buffer will be loaded with the content Y. Y is loaded into your S buffer register. Then after starting the timer, you are going to send the data. To send the data, first you need to load your S buffer register. Then only your transmission channel will be placed with the data whatever you wanted to transmit to your receiving end. Then I wanted to check whether that communication channel is transmitting the data. For that, I have to check my transmit interrupt flag, TI flag. That is whether if my transmit interrupt flag is enabled, if it is equal to 1, it means that my communication channel is ready to transmit the data from my transmitting session to the receiving session. So it is understood that. So first you need to start your timer run bit. Once the timer run bit is selected, you have to place the data onto the S buffer register. After the data is placed, you have to check your transmitting interrupt flag. So once it is, whether it is ready or not ready. So until it is not having any bit, the loop will be run in the same particular line. Then you have to, once the data is transmitted, suppose if the data has been transmitted from your transmitting end to your receiving end, then your TI, that is transmit interrupt flag, is going to get enabled, that is which is equal to 1. When once it is set, then it will come out of the loop and you need to clear your timer interrupt flag, and also you have to stop your timer run bit. So here clearing your timer interrupt, then S jump again. S jump again means again you need to move the data, what you have to move it onto your transmitting channel. This is how you will be writing the program to transmit the letter Y serially with a baud rate of 4800 continuously. So if you do so, here the letter Y will be continuously displayed on your monitor screen. So to view the output, you have to, in a Keel software, you have to go for view option. Under that you will be having S buffer, that is serial window. Exactly you won't be having it as a S buffer. You will be having serial window 1, that is serial window 1, serial window 2, then serial window 3. Likewise you will be having the window. So you can open your serial window 1 to view whether the data is transmitting serially continuously. Thank you, students.